Now let's look at the data mining when we have the text data. And the text data is so widely used, and we know that the businesses or the web is full of the documentation. So it helps us if we can gather insights through the automated mechanisms from those documents. So this is also referred to as information retrieval. So here the candidate databases come from the digital libraries or the large mailboxes that people have, etc. And these documents, as we know, they are not structured in the sense of the business data that is organized in a relational database. Here we need to work with a different types of techniques, and we need to have a mechanism, and typically the information retrieval is done based on identifying the relevant documents using some of the user inputs that may be a keyword or an example document. So this text mining or the information retrieval is different in the sense that here we are not concerned so much about the problems of transaction management and how the updates are happening, etc., which is present in regular transactional databases or which are used for the business purposes. But here we need to work with a different set of challenges, such as the data which is not hardly structured. Though we may claim that a document does have some structure, but the structure is not so standardized like a relational table structure. And we need to work with the approximate search, because we are working with a natural language where the words sometimes can mean different things based on the context. And we need to determine the relevance of the document for a given query or a given purpose. So the common measures that are used when we are working with a text retrieval are one is precision, which is representing the percentage of the retrieved documents that are relevant for the query. So that is, if you have retrieved 100 documents through the process, and out of them only 70 happen to be relevant, then we say that it has got a 0.7 precision. And the recall is that the percentage of documents that are relevant and also retrieved. So for example, there are 1,000 relevant documents in the database, but the process could only retrieve 200 of those documents for the query. So it means that it has retrieved only 200 out of the 1,000 documents that are in fact relevant but are existing in the database, but somehow the query could not retrieve. So here the recall is that it is 200 by 1,000, which is essentially 0.2. So both of these are important because the precision is to ensure that we have no false negatives. I'm sorry, it is that whatever is coming as a positive, it is turning out to be a false positive. So what we are saying is that we have retrieved 100 documents, but out of them 30 are really false positives, in the sense that they are not relevant for the query but somehow got retrieved because of the limitations of the algorithm, etc. So, and then the recall is representing the kind of the depth or the capability it has to get everything from the database. And these are further combined to create a F-score. F-score is representing a harmonic mean of the both recall and precision. And this helps us in balancing out whenever we are creating a solution between recall and precision. Let's say we have got one algorithm which is giving us, let's say one of these recalls and precisions is 1 by 2, and the other one is 1 by 32. And then there is another algorithm which is giving us a recall of 1 by 8, and then also the precision of 1 by 8. And what the F-score does is that it is going to prefer this over this. In this case, if instead of this is 1 by 32, this is have 1 by 3 or so, then this is going to be preferred overall. The F score will be higher. But when there are one is very good and other is very bad, then this prefers which has got more or less similar recall and precision. When we are working with the information retrieval, some of the concept is that a document is typically described by keywords, which we may also call them as index terms. And these index terms will be representing the relevance whenever we are making a query. And sometimes we assign the numerical weights to each the index term. And we are going to look at term frequency and inverse document frequency that in shortly. So those numbers are going to help us differentiate the importance of some of the index terms compared to the other. So if we are looking at a DBMS analogy, the index terms are somewhat like an attribute, and then the weights are representing the attribute values. And as you can see, a document can have a numerous index terms. So for example, a 100-page document can easily have thousands of index items. So if you have looked at any of your textbook and looked at the index pages at the end, you will see thousands of the important terms that are referred in the document. So in that case, what we are seeing is that a large dimensional database, that is what we are ending up with. So when we are creating the index terms, we look at few things. For example, the stop list, we don't want to bother about a word like the or an article like a. And we also look at word stem. So we want to treat run and running to mean the same. And then we may also use the weighted methods. And the models of retrieval can be broadly categorized into a Boolean model, then a vector model, and a probabilistic model. And in a Boolean model, what we do is that we simply look at the index term and determine whether it is present or absent. And in this case, essentially, we are taking a binary approach. If the word is existing, so for example, let's say we are looking at the documents which are related to cricket. If the word cricket is existing, we are saying that this document is relevant. And sometimes we connect those index terms using these Boolean expressions, not, and, or, etc. So then we are going to look at plain or airplane. So what we are saying is that we are collecting the documents which contain either of these terms. And when we are using these keyword-based retrievals, so we create a more complex expression sometimes. So not only we go with and or, we also use not. So say that the document contains about DBMS but not about Oracle. And we also need to consider the synonyms. For example, repair and maintenance mean the same thing. So we need to somehow convey to the software that it needs to treat them in same way. So whenever we are asking for a retrieval of documents for repair, it should also give us the documents which are related to the maintenance. So some of the challenges with this approach is with a couple of things. One is synonymy and other is polysemy. So sometimes we have a document that is representing a specific topic. For example, it is about data mining. But the word mining itself may not appear anywhere. So it may say that this document is all about association rules. And sometimes we also have to face a different set of challenges, that is the polysemy. So a keyword may have different meanings in different contexts. For example, we may look for when a software engineer is looking for a documents which are containing the word mining, the interest is related to really data mining. But if a metallurgical engineer is looking at some of the documents and is interested in mining, you can see that they're looking for a altogether different set of documents. So whenever we do this retrieval in the text data, we need to have a similar documents identified. First, we need to identify the documents that are similar, and then we use the relevance. So the point is that the similarity of the documents, we need to think in terms of how to create. Typically, one approach is that the keywords, but we can take more advanced approach which builds on those keywords. For helping with the processing or the mining of the text documents. So one popular form of index that is created is inverted index, which consists of initially a document ID and posting list, which consists of again the set of keywords which are important for this document. And it maintains another table which consists of the records, which is representing the set of terms, and along with that the posting list where it is there. So thereby we are going to answer the queries which are let's say we want to find out the documents which are associated with a set of key terms or keywords. So here the advantage we are getting is that this type of approach, when we have an inverted index, this is easy to implement this type of queries. But synonymy, polysemy is not well handled, and also posting lists sometimes can be very long, and that means there is a problem with storing and handling. The other approach may be to associate a signature with each one of these document. In a signature, we may represent the terms, and also we may create an order of the terms. So for example, there is a document which refers to cricket 20 times and hockey once. So when we are creating a signature, we can create a ordering saying that the cricket is far more important for this document than hockey. So thereby we may be able to get a greater insight, and when we are doing a mining, this can facilitate. The other approach beyond the Boolean model is the vector space model. So here we represent the documents and queries as a dimensional vectors. So here what happens is that each document is represented by a vector, and within the vector you have got each term is representing possibly the frequency or something related to the word or the keyword. So here we have to find whenever we are looking at a similarity of the document with respect to the query, then we need to look at the correlation between those two vectors. So that correlation can again be found using the techniques such as the Euclidean distance or the cosine between the vectors. And thereby we will determine whether the document is relevant for the query. So here we are representing the term vector. So each one of these terms may represent a dimension. So when there are n terms, it is representing n dimensions. And then each of these terms can have a weightage associated with that is representing the importance of the term within the vector. And thereby we can find out the similarities between these documents. So for example, here we are looking at 3 terms, and for each one of them we are treating them as a different dimension. So essentially it is going to be hypercube, which is having a large number of dimensions. And thereby we are going to fix in each document within some hyperplane which is representing these dimensions. And here in the vector space model, we need to take care of the word stopping, and we also need to work out with the word stemming, because the model does not specify how to handle the stopping words or stemming words. And also it does not specify how to assign the weights. For example, some words are more important than the other. How are you going to assign the weights? And then there are probabilistic models. So essentially they work on probability ranking principles. So essentially for each document, based on several parameters, you determine the probability of this document being relevant for this query. So 5 documents, or let's say 2 documents, one has got a probability of 72%, other has got a 53%, then you say that the one with 72% is more relevant compared to that. So depending on the set of results that you would like to give, you can choose which ones to give. So the models can use all the evidence available. They don't need to depend on one particular evidence, but then they use the probability technique and then probably multiple types of evidence, and then they combine them. And they also may take into consideration the uncertainty that is with respect to both the information representation and also the query representation, whatever information need that you have. That also you may represent. For example, mining, then it doesn't tell you exactly whether somebody is interested in coal mining or data mining. So in this case, the sources of evidence can be wide ranging, can also include the statistical representation of the terms that are coming from the relevant documents or irrelevant documents. And now the question is that when you have got a term, which we have seen is that a term may occur within a document, but we do not want to represent it. Either we are using a vector space approach or we are using the probabilistic model, which again uses the keywords and then want to give weightage based on some parameters. We need to think in terms of how to assign weight to some of the keywords. Some keywords become more important than the other. One can be the term frequency. As we have seen, if there are two documents, one document has got, let's say, the cricket coming in once and hockey coming in 5 times, and another document where cricket is coming 20 times. Hockey is coming once. So we need to recognize that these two documents really have some differences. They are not, one document may be more relevant for one query compared to the others. And the other technique that is used is the inverse document frequency. So it is possible that there are some rarely used terms. So in such case, whenever such a term is being used, we consider the presence of the term is highly discriminative, that differentiates significantly the document from other. For example, the web may have billions of documents, but a document mentioning the name of a specific village in a remote area, there may be very few documents, handful of documents, or there may be hardly any document. So in such cases, what it says is that in spite of many other characteristics, the presence of this a remote village name itself is going to create a differentiation for this document. So this is called inverse document frequency. There we are finding the rare words and looking at the less frequent words being present in particular document. So we can have a term frequency weighting. For example, whenever we have a word is occurring more times than that, a raw term frequency is that straight away saying how many times the term T appeared in D. But sometimes what happens is that you have got 5 documents. One document is 500 pages, another document is 1 page, and the third document is 20 pages, and the fourth document is 2 pages, and so on. So what happens is that now there is a large wide range of sizes in the document. So when you're looking at the relevance, for example, in a 500-page document, cricket may be occurring once, and in the 1-page document, cricket is occurring once, but they may not mean the same thing. So we may have to do some level of normalization. So for that, what we may use is that for one easy way to normalize is that find the maximum frequency of within the document. For example, in the document, large document, there may be another word which is occurring 100 times. So we use that as the basis to normalize. So in this 1-page document, the maximum number of time any term happens is 10. And in the 500-page document, the maximum number of times a term occurs is 100. So we use that as a normalization factor. Thereby, we are going to get a normalized value which we can use to check the relevance of the document for the query. And the other approach we can use is the inverse document frequency. So we are looking at a rare word which is being used. So here what we can see is that, let's say our universe is consisting of 1 million documents. And there is only one document which is containing a very specific term, let's say an example, a remote village name. So then what we do is that the IDF we determine based on this ratio, but to give reduce the range and make it the data more manageable, we can use a logarithmic. So let's say in this case, then what happens is that this 1 million is applied logarithmic terms. So if we use log 10, then we are getting a value of 6. But then there is another term which we are referring to, a small town which is happening in 10 documents. So what happens is that 1 million by 10 and then log, then what we are getting is 5. But if it's a log to the base of 2, we are getting a different multiplier. But so essentially what we are seeing is that this is a differentiation. So this is giving a higher IDF for that remote village compared to another small town or another city name which appears in let's say almost 1 million documents. So it means that the value is coming to 0. Essentially log of 1 is 0. So it does not have any weightage with respect to differentiation. So what we may do is that we can combine that, we can give a weightage which combines the term frequency and also IDF. So then thereby we are going to become more selective or more discriminative with respect to getting the responses for the query. So when we are having a vector space model, so let's say each term is represented by a dimension. So then TF IDF weight is going to represent the value for the dimension. And then we can also have a more complex weighting variants, but thereby this is giving a vector which is where each one of these dimensions is separately differentiated with respect to its value instead of just saying yes or no or making it a Boolean expression. So now we have got when we get a vector for two documents, then we may measure the similarity using a similarity definition such as a simple cosine. So that is a similarity is we take it as a similarity can be a dot product or a normalized dot product or a cosine, whereby we are using these absolute values. So we are in the denominator, so thereby we are normalizing it. So let's take an example. Let's say there are some IDF, we have got some random values, arbitrary values based on some database. So now we are looking at a doc1 which has got text mining search engine text. So we are giving text occurs twice. So for document 1 it is getting a value of 4.8, and then mining is happening only once, so it is getting 4.5, and then search is happening once, 2.1 and 5.4. And similarly we can do it for doc2 which contains different set of keywords, and doc3 which is having a different set of keywords. So now we got a new document which contains text mining. This is all this document contains. So text is happening once, so this is getting once, and mining is getting once. So now we can do a similarity calculation of new document with each one of them, doc1, doc2, doc3. Clearly the similarity with the doc3 is going to be 0 because there is nothing common. But between doc1 and doc2 you can see that this has a greater similarity with the doc1 compared to doc2. So this can be one example whereby one approach whereby you can cluster or combine the documents which are similar. So some of the data mining techniques that you use on the text data is the keyword based association or the classification or a similarity detection based on various features related to the document. Or we may use the link analysis, which is talking about a correlation between the various entities. And we may also do a anomaly or the other approaches, the hyperlinks within the documents, etc. So when we are doing a keyword based association analysis, so we are looking at the set of keywords that frequently occur together. So what we have to do is that we need to look at, we first have to remove do the pre-processing to remove the stemming and then stop words, etc. Then we consider each document as a transaction, and then we apply the mining association mining algorithms to find the association between the documents. And we can do a classification. So here again what we do is that the classification, so we are not using the attribute value pair like a regular database, but we may use the vector space or some other mechanism to represent the document. And then we again do the pre-processing and then use the training set to teach the machine how to classify, and thereby create a classification model, and then classify any of these documents like web pages or the emails, etc. And we can have similarly a clustering. So we put together the documents which are similar together. So here again we have to do a pre-processing, and we apply the clustering techniques, either hierarchical or other forms of clustering techniques. And sometimes we create a network-based clustering. For example, one is related to this and this is related to this. So we may create this type of network to link, because the keywords between there may be some commonality between these two documents and some self-organizing maps, or some of the maps whereby we can relate the documents, some which are closely related or placed in one way, and then which are distantly related or placed in other ways.